This is a Venus transit in 1761. This is in Paris latitude. So I want to show the, if you hold down the minute over here, you can make it, does a pretty good approximation without going too fast. I could probably speed it up when I put it in the editor, but this is a good example. And you can't see Venus, but it's there. I'm going to go through the whole Venus transit. So that didn't have the equatorial mount. I'm going to turn the equatorial mount on because it's easier. You can see how it tilts the terrain. Okay, so the point of this video is to dispel the notion that retrograde has anything to do with parallax or is an optical illusion, that it's a real motion of the planet. So let's go over right ascension real quick. Right ascension is the celestial equivalent of longitude, but instead of being measured in degrees, it's usually given in hours, minutes, and seconds. Celestial coordinate system divides the sky into 24 hours of right ascension, and 1 hour of right ascension corresponds to 15 degrees. So decreasing right ascension means that the object is moving toward the west along the celestial equator. Increasing right ascension means that the object is moving toward the east. Let's keep that in mind. Okay, now I've gotten rid of all the other information. This is just right ascension and declination. This is for the sun. And we'll step through this hour by hour, and we'll see the right ascension increase, and we'll see the declination increase, which means the sun is going up. 4 hours, 56 minutes, 50.59 seconds. So 57 minutes, 57:11, 57:21, 57:31, 57:42, 57:52. Now we'll watch Venus, which direction it moves. And so we'll take a look at decreasing right ascension. Decreasing right ascension means that the object is moving toward the west along the celestial equator. So we'll see Venus will have a decreasing right ascension, meaning it's moving toward the west, which means it's in retrograde. Let's step through. So we've got 4 hours, 57 minutes, 55 seconds, 57 minutes, 49 seconds, 57 minutes, 43 seconds, 57 minutes, 36 seconds, 57 minutes, 30 seconds, 57 minutes, 23.8 seconds, 17 seconds. We can clearly see the sun is prograde, Mercury's going the other way, it's retrograde, and right ascension and declination are the locations. It's where they're at in reference to the zodiacal constellations. The time of year tells you which zodiacal sign you're in, and in this case it's June, so the sun and Venus are both in Taurus. In this example, we can see that Venus and the sun have the same right ascension. So it's 4 hours, 57 minutes, and depending on which way either one of them are going, for the sun, it's going to the east, so its seconds are going to go up, and Venus is going to the west, so its seconds are going to go down. Now they'll have exactly the same right ascension as their center points line up, but the declination isn't going to be the same because their altitudes are different. So as we've seen using Stellarium to watch the Venus transit, it's impossible for the fakers to invoke their parallax gimmick to explain away Venus's backward motion, since the sun is directly behind Venus the entire time. And what you'll find on the internet amounts to just about zero when it comes to a Venus transit. All you'll get is these kooky animations like this one or this one. So as we can plainly see, the retrograde as an illusion paradigm falls to pieces simply by looking at the right ascension and declination feature in Stellarium. And I encourage everyone to do this at home. Stellarium is a free product, and